Okay, today we are talking about geometric sums. The sum of a geometric sequence can be found, so this would be my geometric sequence. So A1 is your first term, so then we have A1 times your R, that's your ratio. A1 times your R squared. A1 times your R cubed, blah blah blah, all the way to A1 to your times your R to the n minus 1. Okay, so this gives you what your geometric sequence is, depending on how many terms you have. To find that, we have Sn, so this is sum, is equal to, this is sigma, so we talked about sigma last time, I equal to 1 to n, then you have your A1R, I minus 1. So this is what we did yesterday. This is the same function how we used to figure out our formula. Okay, we need to take the information from this and use it into this equation. So A1 times 1 minus R to the n over 1 minus R. This will give us the sum for whatever whatever value we're looking for, so depending on what n is. So how many of the first terms. So example 1. I want to find the sum of this function from 1 to 12. Okay, so 4 times 0.03 I minus 1. Okay, so I could technically go and find the first term, second term, third term, all the way up to 12 and add all those up. Okay, but using this equation right here, make it much easier just to go to find the first and the last term. Okay, so A1 is 4. Okay, your R is 0.3. And my N is 12. Okay, so to find the sum, Sn equals, I have my A1 times 1 minus my R is 0.3 to the N, so 12, over 1 minus 0.3. Okay, when I do that, you need to be careful how you plug it into the calculator. So let's see. I'm going to take 4 times, I'm going to put double parentheses, 1 minus 0.3 to the 12 divided by 1 minus 0.3, okay, and get 0.5 or 5.714. Okay, so that would be the sum of the first 12 terms. Okay, that seems much easier to do than finding the first, second, third, fourth, all the way up till 12 and adding them all up. Okay, then there's another way to, this is if it's finite, okay? The sum of an infinite sequence so this is when your R, the absolute value of your R, is less than 1. Okay. Still the same sequence as before. This time our sum is equal to 0 to infinity. We can find it by taking your A1, that should be a 1, not an I, A1 over 1 minus R. Okay. So, example 2, I want to find the sum of this infinite sequence. So n equals 1 and I'm going to infinity. 4 times 0.6 to the n minus 1. Okay, if we look, what information do I need for here? I need to know my first term and I need to know my R. So my first term is 4 and my R is 0.6. Okay, so to find the sum, I take 4 divided by 1 minus 0.6. Okay, so again, let's do this in the calculator. Clear this from last. 4 divided by 1 minus 0.6. Okay, when I do that, I get 10. So that means if I keep adding all the terms, it gets closer and closer and closer to 10. So that would be your answer for this. A6 is page 670, numbers 53 through 56, 79 through 80. Please let me know if you have any questions, and good luck.